Hello student, today we'll see IO ports. There are up to 5 general purpose IO ports are available in PEAK 18458. So by general purpose IO ports, that means we are assigning that port pin as an input or output. So the ports are required to interface any external peripheral devices like ADC, external ADC, then LCD, motor, switches, keyboards, joysticks. So if you want to interface these peripherals to microcontroller, you need a IO ports. If you choose different configuration or different chip from microchip, different IC from microchip, the port count will be different. In some microcontroller it comes with a 2 ports, some microcontroller it comes with a 3 ports, some with the 4 ports. But in PEAK 18458, we are having 5 general purpose IO ports. Some pins of IO ports are multiplexed with an alternate function from the peripheral features on the device. What is meant by it? Each pin from microcontroller PEAK 18 having multiple functions. The one pin can perform more than 2 functions. For example, if I am talking about the port A, the port A having input as well as output port, and third function is as a analog input to ADC, inbuilt ADC. Some pins are assigned as a serial communication pins, RX and TX. Some are used for the CAN bus, some used for the motor driving, some used for the interrupt generations. So each pins from each ports having multiple functions. Each port has 3 registers for its operation. Trace register, the data direction register, port registers read the level on the pins of the device. Level means it is high or low. Then LAT registers, output latch registers. We cannot directly send the data through port. First of all, we have to latch that data into latch register, and then we'll send the data through port. The setting trace A bit will make the corresponding port A pins and output. Clearing trace A bit will make the corresponding port A pin and an output. What is mean by it? If you want to assign the port pin as an input, for example, if you interface switch to port A, that means you are giving inputs to port A. So you have to set that particular bit or whole port set of 1 1. If you want to interface LCD or LED or motor, that means you are giving output to that port. So clear that port or give the 0 to that particular bit or whole port. Here I taken one example. Move LW 0 cross 0 0. Move WF trace B. I'm loading 0 0 into WRE register, and from WRE register it will transfer to file register trace B. That means assign port B as output. Then move LW 0 cross 55. I'm taking alternate 0101 and sending that WREG register into file register port B. That means I'm alternating and assigning input output. So these registers are in SFRs. The locations are fixed in SFR. Then port A is 7 pin, port B, C, D are 8 pins, and port E are 3 pins. In this pin diagram we can see the port A over here, port 0, port A0, port A1, 2, 3, 4, 5 and 6 is over here. 0 to 6, that means 7 pins are assigned. You can see over here port A0 is assigned as an input or output. Then It use AN0 means it is assigned as a one input to analog input to inbuilt ADC, or we can use a reference voltage. Then here RA2 is assigned as an input output as well as analog input to or channel 2 to inbuilt ADC, and as well as V reference to that same inbuilt ADC. We can configure in our program. The manufacturer gives the facility to configure the pins. What is the difference between the latch and port? A write to the port register the data value to the port latch. So the anything is write into the port, that the value is into latch into the that port latch. If you want to write the into the latch register, write that value into that port latch. If you want to read that from the port, you can read the data from that port latch. If you want to read from the LAT registers, that the data it should be read from that port. So this is the difference between the port and latch. We can in port we can just observe the level of that port, whether it is high, whether it is low or dry state. In latch, the actual data is in latch register. Thank you, student.